Hi, this is Philip Rockwell. I'm doing problem number 10 out of section 4.2. Here is your initially given equation and then your initial values. The first thing we want to do is write out our derivative equivalents. So we have our Laplace transformation for the second derivative of x equals s squared chi of s minus s times the initial value of x minus the initial value of x prime. And then for the Laplace transformation for x prime equals s chi of s minus the initial value of x. Next, what you want to do is sub it into the initial equation. So you sub in the equivalents for x double prime minus 3 times the equivalents of x prime plus 2 times just chi of s, which is your Laplace transformation of small x, equals the Laplace transformation of t. And looking at the table, you know that the Laplace transformation of t is 1 over s squared. So this whole side equals 1 over s squared. Then what you want to do is sub the initial values given. We were given the initial value of x equals 0 and the initial value of x prime equals 2. And then subbing those in the places in this equation, you get this. And then what I did was just combine the values for chi of s, and you get a equation here that you can multiply by. And then rearranging that equation, you can solve for chi of s, and you get this. And then simplifying further and also factoring the denominator, this would be your final answer for chi of s. And then setting up a partial fraction, because there's an s squared and 2 factors, you need four letters for your partial fraction. And this is the partial fraction that is used for this problem. And then you can set the top part of all the fractions equal to each other, so you have 2s squared plus 1 equals as times s plus 1 times s plus 2 plus b times s plus 1 times s plus 2 plus cs squared times s plus 2 plus ds squared times s plus 1. So going through to solve for a, b, c, and d, first we set s equal to 0, and you get 0 plus 1 equals a to the 0, because 0 makes this s 0, so everything else is 0. B times 1 times 2 plus c, which is also 0 because s is 0, and d, which is 0 because s is 0. So you're left with 2b equals 1, which makes b equal to 1/2. And then next you set s equal to -1, which makes a, b, and d cancel because of the s plus 1 term. So you're left with 2 plus 1, and then c is c times 1 times 1, so you get that c equals 3. Next you set s equal to -2, which cancels the terms in a, b, and c to find out d. So you have 4 times 2, which is 8, plus 1 is 9, and then a, b, and c are 0, and then you have 4 times d times -1. So you have -4d equals 9, which makes d equal to -9/4. And then for this last step to solve for a, you set the coefficients for the s cubed term, which is in a, c, and d. You have s cubed when you multiply this out. So that makes a plus c plus d equal to 0 because there's no s cubed terms on the left-hand side of the equation. So you sub in the values you already found for c and d, so you get a plus 3 minus 9/4 equals 0, which makes a equal to negative 3/4. Alright, and then you want to go and sub into the partial fraction equation, which is our a over s plus a over s squared plus c over s plus 1 plus d over s plus 2. So we sub in all of our values and then take the inverse Laplace transformation of chi of s and of our partial fractions equation. And we get x of t equals negative 3/4 the inverse Laplace transformation of 1 over s plus 1/2 the inverse Laplace transformation of 1 over s squared plus 3 times the inverse Laplace transformation of 1 over s plus 1 minus 9/4 times the Laplace transformation of 1 over s plus 2. And then looking at the table again, if you can see that, our first term is 1 over s, so it's right here, and that's going to equal 1. Our second term is 1 over s squared, which is going to be t. And then our third term is 1 over s plus 1, which is the same as 1 over s minus negative 1, which would be this term here. So we'd have e to the negative 1t, or just e to the negative t. And then for our fourth term, we have 1 over s plus 2, which is the same as 1 over s minus negative 2, which is also going to be this term here. So you'd have e to the negative 2t. And then you can see I wrote those values in, and then multiplying the fractions by the terms and simplifying over a single fraction. This is the final answer that you get. Thank you.